right, let's complete the square. So we were given these two pieces. So I was given an x by an x. I'm just going to outline this. So I have an x by an x, and I have 8 of these skinny x's. There's 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to be putting these around here to build a perfect cube. So, boom. If I put 3 here, I got to put 3 down here. I got 2 left, 4, and 4. So now I've got these. We have 4 up here and a 4 over here. Right now, if we were to multiply through, we would get x squared. X times 4 is 4 x's. Oops. And we have another 4x right here. So if I were to just have this much so far, I've got x squared, that's what I was given. 4x and another 4x become 8x. So what do I need in here? How many little cubes would I need to fill in this little space? Well, I can just pull some out, but I know I'm going to have to fill through 1, 2, 3, 4, 4 times. So by putting a 16 on the end, if I wanted to add 16, since those weren't given to me, I also have to later subtract 16. This is just a placeholder, so let's focus on these ones. What is x plus 8x plus 16? Well, that's an x and a 4 and an x and a 4 together. So if I were to rewrite it, I would get x plus 4 2 times. I'm going to add that I'm going to minus that 16 on the end. So everything right here became this, and I had to subtract 16 on the end to keep my equation balanced. Hi y'all. Here is another visual example of completing the square. So we want to build a square that has to do with this. I'm going to focus on these for right now. So I've got an x squared. That is an x by x. And then I want to build 4 around it. So I've got 1, 2, 3, 4 of these long ones. I'm going to be building a square. 1, 1, 2, and 2. So I've got a 2 here and a 2 here. If I was to go through, this gives me x squared. This gives me 2 x's, and this gives me 2 x's. So what goes in right here? Well, this empty space needs 4 baby cubes if I want it to have a perfect cube. So let's look at this one. X squared plus 4x, I need 4 pieces. I had 2 pieces. If I add 4 on this side, I'm going to have to subtract 4 over here. So now I've got x squared plus 4x plus 4. 2 take away 4 is -2. What this is saying is that I needed 4 And if I put 4 in, I have to take 2 away to go back to what I had. Let's write this whole picture in vertex form. This shape is an x by 2 and an x by 2. So we're going to do x plus 2 squared minus 2, and I'm done. There is a visual example of completing the square when we're trying to fill out this space. All right, so this is in the packet, question 4A on page 6. So they want us to go from standard form into vertex form. In vertex form, we want it to look like this x plus or minus h squared plus or minus k equation. So we're going to figure out what to do with this one to make it look like that. We're going to use this process called completing the square. The reason why we're going to complete the square is because we want it to be something that has the same dimensions on top and bottom. So let's just get started with the items that I have. I've got an x squared, one of these big ones. That's our x squared. 6x, so we need 1, 2, 3, 4, 5, and 6 of these. So we are going to try to put these in a format where I'm going to be building a perfect square. So if I put them all down right here, that's a rectangle. So I want to make sure that everything's even on each side. So if I put 1 each on there, I would need 1 in the middle to make a square. If I put 2 more, looks like I'm going to be needing 4 and so on. So I want it to have 6, so I'm going to put 6 on the outsides. So I have dimensions that look like x plus 3 and x plus 3 over here. If we were to multiply these together, what has to go right here? Well, right there, I'm going to need 9 little baby cubes. So I'm going to take this first part, I'm going to rewrite it over here. F of x equals x squared plus 6x. I need 9 cubes. So this is this empty box over here. I'm going to continue my equation and add 30 at the end. Now, if I need 9 and I had 30, well, let me just take 9 off of that. Another way to think about this is that if I just randomly add 9, to keep my equation balanced, I'm going to have to subtract 9 as well. So I'm going to be putting x squared plus 6x plus 9, and then whatever this is. 30 take away 9 plus 21. So what is this saying? Here is my perfect square. That's my x plus 3 and x plus 3. But then I had some left over because they were going to give me 30 single units. So I have 30 or 21 left over. So if I want to put it in vertex form, I'm going to take my perfect square and write it as something squared. This statement is this big figure. So we've got x plus 3 to the power of 2 plus 21. And we're done. That is us in vertex form. Let's try one more. Oops. All right, let's do completing the square when we don't have our cubes and blocks. So we've got f of x equals x squared minus 14x plus 50. We're going to be focusing on these first. So I know I've got an x squared and I've got negative 14, which means I'm putting in 7 over here. 1, 2, 3, 4, 5, 6, and 7. Because that's half of this. And I'm putting in negative 7 over here. 1, 2, 3, 4, 5, 6, 7. So I'm putting in an x, a -7, an x, a -7. So how many cubes should be fitting in right here? Well, I know that's going to be a 7 by 7 space, so that's going to be 49. If I want to create or force this to be a perfect cube, perfect square, I've got x squared minus 14x, and then I need 49 more. So I was creating a value that would make this x by -7 a perfect square. But this positive 49 didn't come from anywhere, right? They only gave me 50. So what I can do, of the 50 that they gave me, I can take out 49 and figure out what's left over. Just 1. So if I took all these 50s and filled in this little space with all my little baby pieces, I would have 1 left over. And this piece gets rewritten as x minus 7 to the power of 2. Brr, 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 I'm in vertex form. So this was 4b. Let's do 4c. But I'm not going to draw any pictures. F of x equals x squared plus 24x plus 42. I'm going to focus on these ones. I'm going to take half of this value and then I'm going to square it. That's what I did over here. We took half of this -14 and then we squared it to get that third term. So I'm going to have x squared plus 24x. I'm going to put something in there. I'm not going to touch the 42. But whatever I add to this equation, I'm going to have to minus it over here as well. So this 49 that we had was also minused on this side. So whatever we put here, we have to minus it on the other side to keep my equation balanced. Okay, half of 24, and then we're going to square it. So we're going to take the b value, cut it in half, and then raise it to the power of 2. So that would become 24 over 2 squared gives me 12 squared. 12 times 12 is 144. If I minus it on the other side, I'll keep my equation balanced. Now let's change this into factored form. So we've got to figure out, this first will start x squared, and we either want to do the square root of this value or we want to do half of this one. It's going to be plus 12. Oops, that shouldn't be x squared. X plus 12 power 2. If you weren't sure if you're doing this right, if you FOIL it backwards, it should match that last one. All right, let's deal with this. 42, take away 144. If you're not good with negatives, you could pop out a calculator. Maybe if my phone wants to work. 42 minus 144 gives us negative 102. And we're done. Let's do 4e. So we're just going to do this one purely procedural. I'm going to leave the first 2 terms. I'm going to leave some space, add 50. I'm going to add something here, but I'm also going to minus it on the other side. So what's going to go in this space? It's half of this term squared. Remember, b over 2 squared, which gives me negative 18 over 2 to the power 2, which gives me negative 9 power 2. Negative 9 power 2 is 81. So if I put an 81 here, I got a minus 81 over here. I'm going to factor this one, so it's going to be something like this. The first term is just going to be that value without the power of 2. And then I can either take the half of this, or I can take the square root of this. Either way, you're gonna get -9. The reason why it's not +9 is because look, it has to match this sign. So there's that. Now we're gonna combine these. 50 take away 81. You can grab a calculator if you want. And you get 50 minus 81, -31. So here we are. We converted from standard form of ax squared plus bx plus c, and we changed it to vertex form. In this case, it was x minus h squared minus k. Cool. All right, we're gonna close our video off with a step-by-step completing the square with directions on the sides. So step 1, rewrite your problem. With space after the second term. So let's say I gave you the equation f of x equals x squared minus 18x plus 50. I've got ax squared, there's a 1 there, ax squared plus bx plus c. We're going to rewrite it with space between our b and our c terms. So we've got x squared minus 18x. I'm going to leave some space plus 50. Step 2. We're going to add and subtract this part of the equation. Half of your b value squared. So what is that? In this problem, half my b value, so that would be -18 over 2 raised to the power of 2. That would be -9 squared. -9 squared is 81. So I'm going to add 81 here, and then I'm going to subtract 81 on this side. Step 3. Focus on the 3 terms. Oops. Focus on the first 3 terms. If I want to write that in vertex form or something squared, you have to imagine, like, what would this be on the box? It would be x and an x, and then half of that, so -9, -9. What's going to happen is we're going to get -9x, -9x, which gives us -18x. And we would also have -9 times -9, which is 81. So we know we're doing this right. X minus 9, that's the dimensions on my box. X minus 9, 2 times. Last step. Combine like terms. So my like terms would be right here. That plus that would give me, I'm not sure, -31? Yeah, I think that's right. And I'm done. I could just come up with a really random one and do it really, really fast, which would be like x squared minus 12 plus 17. Now I'm just creating random numbers. So what am I going to do? I'm going to put some space. I want to take half of this term and then square it. So half of that is -6. If I square that, that's going to be 36. If I add it, I got to subtract it as well. Focusing on this, it's half of this term, so it's x minus 6. And then I would combine these terms. So 17 minus 36, you can get a calculator if you don't want to do that in your head. 17 minus 36, -19. And I'm done. So I went from standard form to vertex form by means of completing the square. The end.